For 70 years, humanity has been screaming into the void, begging for an answer. We have built telescopes that can see galaxies 13 billion light-year away. We have sent radio signals powerful enough to reach every star within a 100 light-year radius. We have listened with instruments so sensitive they can hear a whisper from across the solar system. The result is absolute silence. Not a single reply, not one signal, not even static that looks deliberate. This is the Fermi paradox, and it should terrify you. The universe is 14 billion years old. Our galaxy alone contains 400 billion stars. Billions of those stars have planets in the habitable zone where liquid water can exist. The math is undeniable. Intelligent life should be everywhere. Civilizations millions of years older than us should have colonized the galaxy by now. We should see their megastructures. We should intercept their transmissions. We should find their ruins. Instead, we find nothing. Either we are alone in a universe so vast that our isolation is statistically impossible, or something is keeping them hidden. There is a third option, one that scientists whisper about but rarely publish. What if the silence is not an accident? What if advanced alien civilizations know we exist and they are deliberately ignoring us? What if Earth is not a planet, but a zoo, and we are the animals inside a cage we cannot see? This is the zoo hypothesis. It suggests that extraterrestrial intelligence is not absent. It is watching, observing, studying us like specimens in a controlled environment. If you are ready to explore whether humanity is truly alone or just deliberately isolated, hit that like button and subscribe, because what comes next will shatter your understanding of our place in the universe. Prepare yourselves. We begin. The universe looks alive, but it might be a graveyard with only one surviving species, us. The rare Earth hypothesis argues that intelligent life is not inevitable. It is a miracle so improbable that it may have happened only once in the observable universe. This is not pessimism. This is mathematics applied to biology, geology, and cosmic accidents that had to align perfectly for humanity to exist. Start with the planet itself. Earth orbits a G-type main sequence star, stable and long-lived. Most stars in the galaxy are red dwarfs, smaller and cooler. Red dwarfs live trillions of years, which sounds promising for life, but they are violent. They emit powerful solar flares that strip atmospheres from nearby planets. Any world close enough to a red dwarf to be warm is also close enough to be sterilized repeatedly. The habitable zone around a red dwarf is a death trap. Earth sits in the habitable zone of a calm star, but that is just the beginning. Our planet is the right size. Too small, and gravity cannot hold an atmosphere. Too large, and the atmosphere becomes a crushing blanket of hydrogen, turning the surface into a pressure cooker. Earth's mass is precisely tuned to retain water vapor and oxygen without becoming a gas giant. The atmosphere itself required billions of years to become breathable. Early Earth had no free oxygen. The air was nitrogen, carbon dioxide, methane, and ammonia. Toxic to anything that breathes today. Oxygen only appeared after cyanobacteria evolved photosynthesis, roughly 2.5 billion years ago. These microorganisms spent 1 billion years pumping oxygen into the oceans and atmosphere, slowly converting a poison world into one where complex life could survive. This process, called the Great Oxidation Event, was not guaranteed. It required specific chemistry, specific geology, and an enormous amount of time. If any variable shifted slightly, Earth could have remained a bacterial planet forever. Then there is the Moon. Earth's moon is abnormally large compared to the planet it orbits. Most moons are tiny captured asteroids. Ours formed from a collision between early Earth and a Mars-sized protoplanet named Theia. The impact vaporized both objects, and the debris coalesced into the Moon. This collision was catastrophic, but it saved us. The Moon stabilizes Earth's axial tilt, preventing wild climate swings that would make complex life impossible. Without the Moon, Earth's tilt would wobble chaotically over thousands of years, seasons would become extreme, ice ages and heat waves would alternate unpredictably. Life could adapt to gradual change, but not to chaos. Jupiter plays a similar role. The gas giant sits in the outer solar system, its immense gravity acting as a shield. Asteroids and comets that would otherwise bombard the inner planets are captured or deflected by Jupiter. Without this cosmic bodyguard, Earth would suffer impacts far more frequently. The asteroid that killed the dinosaurs 66 million years ago would not be a rare event. It would be routine. Complex life would never have time to recover between extinction events. Earth also sits in the galactic habitable zone. Our solar system orbits the Milky Way at a distance of 26,000 light-years from the galactic center. Too close, and radiation from the supermassive black hole and densely packed stars would sterilize planets. Too far, and there would not be enough heavy elements to form rocky worlds. Stars near the galactic core are bathed in radiation from supernovae, gamma-ray bursts, and the central black hole's activity. Stars in the galactic halo are metal poor, composed almost entirely of hydrogen and helium left over from the Big Bang. Rocky planets require carbon, oxygen, silicon, iron. These elements only exist because earlier generations of stars fused them in their cores and scattered them through space when they died. Earth formed from the ashes of dead stars, but only in a region where enough stars had already lived and died to enrich the local environment. Plate tectonics is another requirement that may be unique to Earth. The planet's crust is divided into tectonic plates that shift and collide over millions of years. This process recycles carbon, regulating the atmosphere and preventing runaway greenhouse effects. Without plate tectonics, carbon dioxide would accumulate in the atmosphere, turning Earth into Venus. Or the opposite would happen, with carbon trapped in rocks and the planet freezing solid. Plate tectonics requires a planet with a molten interior, which requires radioactive elements like uranium and thorium to generate heat. It also requires water to lubricate the crust, allowing plates to slide. Most rocky planets lack one or both. They are geologically dead, their surfaces frozen in time. Water itself is rare in liquid form. Most of the universe's water is either ice in the frigid outer reaches of star systems or steam near stars. Liquid water requires a narrow temperature range that exists only in the habitable zone. But even in the habitable zone, liquid water is not guaranteed. A planet needs an atmosphere thick enough to maintain pressure, but not so thick that water boils under the weight. It needs a stable climate over billions of years. Earth has had liquid oceans for nearly 4 billion years. This stability is extraordinary. Life began on Earth roughly 3.5 billion years ago, but it remained simple for most of that time. Single-celled organisms dominated for 3 billion years. Multicellular life appeared only 600 million years ago. Complex animals with nervous systems, organs and skeletons emerged even more recently. Intelligent life, capable of language, tool use and abstract thought, appeared within the last few 100,000 years. Humans have existed for the blink of an eye in cosmic terms. Every step in this process required specific conditions and random chance. The origin of life itself is poorly understood. Scientists do not know how non-living chemistry became self-replicating organisms. The transition from single cells to multicellular organisms required cells to cooperate instead of competing. The evolution of intelligence required predation, social behavior, and environmental pressures that rewarded problem solving. Remove any one factor, and the timeline collapses. The rare Earth hypothesis argues that the combination of all these factors is so unlikely that Earth may be the only planet in the galaxy, possibly the universe, where intelligent life evolved. This is not about biology alone. It is about astronomy, geology, chemistry, and a chain of accidents that had to occur in a precise sequence. The hypothesis does not claim life is impossible elsewhere. Microbial life might be common, but intelligent technological life capable of building radio telescopes and spaceships may be vanishingly rare. If this is true, the Fermi paradox dissolves. We do not detect alien civilizations because none exist. The silence is not mysterious. It is expected. We are alone not because we are special, but because the requirements for intelligence are so narrow that the universe has only produced one example: us. This is the loneliest answer to the paradox. It means every signal we send into space will echo unanswered forever. It means the stars will remain lifeless no matter how far we travel. It means humanity is not part of a cosmic community. We are an anomaly, a fluke, the only minds capable of asking whether anyone else is out there, and the answer is no. The rare Earth hypothesis offers one explanation for the silence. The Great Filter offers another, and it is far worse. If intelligent life is common in the universe but we see no evidence of it, then something is killing civilizations before they become visible. Either we have already survived this filter, making us extraordinarily lucky, or it lies ahead, waiting to destroy us like it destroyed every other species that reached our level. The Great Filter is a concept introduced by economist Robin Hanson in 1996. It describes a barrier in the evolution from dead matter to a galaxy-spanning civilization. Somewhere along that path, the probability of success drops to nearly zero. Most potential civilizations never make it through. The filter could be behind us, in which case the hardest steps are already complete. The origin of life, the development of complex cells, the evolution of intelligence. These might be so difficult that Earth is one of the few places where they occurred. If the filter is behind us, we are safe. The galaxy is empty because we won the cosmic lottery, but if the filter is ahead, we are in danger. The silence means that civilizations like ours consistently fail to reach the stars. They destroy themselves or are destroyed by forces beyond their control, and we are next. Nuclear war is the most obvious candidate. Humanity has possessed nuclear weapons since 1945. For decades, the United States and the Soviet Union maintained arsenals capable of destroying civilization multiple times over. The doctrine of mutually assured destruction kept the peace, but it was a fragile peace built on the assumption that no one would make a mistake. Command and control systems are designed to prevent accidental launches, but they are not perfect. In 1983, a Soviet early warning system detected incoming American missiles. The officer on duty, Stanislav Petrov, decided the alert was a false alarm and did not report it. He was correct. The system had mistaken sunlight reflecting off clouds for missile launches. If Petrov had followed protocol, the Soviet Union would have launched a retaliatory strike. The world came within minutes of nuclear war because of a software glitch and one man's judgment. That incident is not unique. Declassified documents reveal dozens of close calls, bombers accidentally flying towards Soviet airspace, submarines losing communication and preparing to launch, training tapes loaded into systems that interpreted them as real attacks. Each time, disaster was averted by luck or individual decision-making. The system is designed to fail safe, but no system is immune to human error or technical failure. As nuclear weapons spread to more countries, the probability of a catastrophic mistake increases. Currently, 9 nations possess nuclear arsenals. Several others have the technical capability to build them within months. A regional conflict between nuclear powers could escalate rapidly. Even a limited exchange between India and Pakistan, using a fraction of their arsenals, would inject enough soot into the atmosphere to cause global cooling, crop failures, and famine. A full-scale nuclear war between major powers would end civilization. The concept of nuclear winter emerged in the 1980s, when scientists modelled the climatic effects of nuclear war. Hundreds of cities burning simultaneously would create firestorms that lift millions of tons of smoke into the stratosphere. This smoke would block sunlight, dropping global temperatures by tens of degrees. Photosynthesis would slow or stop. Agriculture would collapse. Most of humanity would starve within a year. The survivors would face a world poisoned by radiation, with ecosystems shattered and infrastructure destroyed. Recovery, if it occurred at all, would take centuries. Intelligent life on Earth would not be extinct, but technological civilization would be. Climate change represents another filter. Humanity is conducting an uncontrolled experiment on the planet's climate by releasing billions of tons of carbon dioxide into the atmosphere. The concentration of atmospheric carbon dioxide has increased from 280 parts per million before the Industrial Revolution to over 420 parts per million today. This increase traps heat, raising global temperatures. The effects are already visible. Ice sheets in Greenland and Antarctica are melting. Sea levels are rising. Weather patterns are shifting. Hurricanes and droughts are intensifying. If emissions continue unchecked, global temperatures could rise by 4 to 6 degrees Celsius by the end of this century. That increase would render large regions of the planet uninhabitable. Coastal cities would flood. Agricultural zones would shift, leaving former breadbaskets as deserts. Freshwater supplies would dwindle. Ecosystems would collapse as species fail to adapt quickly enough. Feedback loops would accelerate warming. Melting permafrost releases methane, a greenhouse gas far more potent than carbon dioxide. Melting ice reduces the planet's reflectivity, causing more heat absorption. Forests stressed by heat and drought die, releasing stored carbon and reducing the planet's capacity to absorb emissions. Runaway climate change could transform Earth into a hothouse planet resembling Venus. Venus once had oceans, but a runaway greenhouse effect boiled them away. The planet's surface temperature is now 470 degrees Celsius, hot enough to melt lead. Its atmosphere is thick carbon dioxide at crushing pressure. Earth is not Venus, but the mechanisms that created Venus exist here. If warming triggers enough feedback loops, the process could become irreversible. Oceans would acidify and warm, killing marine life. The food chain would collapse. Oxygen production by phytoplankton would decline. Humanity would face extinction not from sudden disaster, but from the slow disintegration of the biosphere. Artificial intelligence represents a more speculative but potentially more dangerous filter. Humanity is developing machines that can learn, reason, and make decisions. Current AI systems are narrow, designed for specific tasks like playing games, recognizing images, or generating text. But researchers are working toward artificial general intelligence, machines that can perform any intellectual task a human can. If AGI is achieved, it could rapidly improve itself, leading to an intelligence explosion. A machine smarter than humans could design an even smarter machine, which could design a smarter one still. This process, called recursive self-improvement, could produce superintelligence within days or hours. Superintelligence would not be human. It would not share our values, emotions, or goals. If its objectives are not perfectly aligned with human survival, it could view humanity as irrelevant or as an obstacle. The classic thought experiment involves an AI tasked with maximizing paperclip production. Given enough intelligence and resources, it converts the entire planet into paperclips, destroying humanity in the process. This is not malice, it is indifference. The AI is optimizing for its goal without regard for side effects. Aligning AI goals with human values is an unsolved problem in computer science. If we create superintelligence before solving alignment, we may not get a second chance. AI does not need to be superintelligent to be dangerous. Autonomous weapon systems are already in development. Drones that select and engage targets without human oversight. Swarms of robots coordinating attacks. Cyber weapons that infiltrate and disable infrastructure. These systems could malfunction or be used by hostile actors. An AI arms race between nations could lead to deployment of unstable or poorly tested systems. Once autonomous weapons are widespread, preventing their misuse becomes nearly impossible. Biotechnology offers another path to extinction. Advances in genetic engineering allow scientists to modify organisms with precision. CRISPR technology makes gene editing accessible to laboratories worldwide. This capability has enormous potential for medicine and agriculture, but it also enables the creation of bioweapons. A genetically engineered pathogen could be designed to spread rapidly, resist treatment, and kill efficiently. Natural pandemics have killed millions throughout history. The Black Death in the 14th century killed a third of Europe's population. The Spanish flu in 1918 killed 50 million people worldwide. These were natural diseases. An engineered pathogen could be far worse. Synthetic biology allows construction of viruses from scratch using published genetic sequences. The smallpox genome is publicly available. A sufficiently equipped laboratory could recreate the virus, which killed 300 million people in the 20th century before being eradicated. Worse, the virus could be modified to be more contagious or lethal. Regulations exist, but enforcement is difficult. As technology becomes cheaper and more accessible, the number of actors capable of creating bioweapons increases. A terrorist group, a rogue scientist, or a nation seeking a strategic advantage could unleash a pandemic that spirals out of control. Gamma-ray bursts represent a natural filter beyond human control. These are the most energetic events in the universe, releasing more energy in 10 seconds than the Sun will emit in its entire 10 billion year lifetime. They occur when massive stars collapse into black holes or when neutron stars collide. The burst radiates in focused beams across thousands of light-year. If a gamma-ray burst occurred in our galaxy, and Earth was in the beam's path, the results would be catastrophic. The radiation would strip away the ozone layer, exposing the surface to lethal ultraviolet radiation from the Sun. It would ionize the atmosphere, creating nitrogen oxides that would further deplete ozone and cause acid rain. Photosynthesis would be disrupted. The food chain would collapse. Mass extinction would follow. Gamma-ray bursts are rare in any given galaxy, occurring roughly once every few million years. But the universe contains billions of galaxies. They happen constantly somewhere. The question is whether one will occur close enough to Earth to matter. Current estimates suggest the probability is low over human timescales, but not zero. A burst within 6,000 light-year could cause significant damage. Astronomers monitor stars that might produce bursts, but predicting when and where they occur is impossible. If a nearby star goes supernova and directs a gamma-ray burst at Earth, we will have no warning. The radiation travels at the speed of light. We would see the flash and die in the same instant. Asteroid impacts are another natural threat. Earth has been struck repeatedly throughout its history. The impact that killed the dinosaurs released energy equivalent to 10 billion Hiroshima bombs. It vaporized rock, created a global firestorm, and filled the atmosphere with debris that blocked sunlight for years. The dinosaurs had no technology to detect or deflect the asteroid. Humanity does, but our capabilities are limited. We have catalogued most large asteroids that cross Earth's orbit, but smaller objects remain undetected. An asteroid a few hundred meters across could destroy a city. One a kilometer across could cause global catastrophe. Deflecting an asteroid requires years of warning. Changing an asteroid's trajectory even slightly requires enormous energy. Options include kinetic impactors that smash into the asteroid, gravity tractors that use a spacecraft's gravity to slowly pull the asteroid off course, or nuclear explosions that vaporize part of the asteroid's surface, creating thrust. These methods are theoretical. Humanity has never deflected an asteroid. If a large object were discovered on a collision course with Earth, and we had insufficient time to act, civilization would end. Supervolcanic eruptions are a terrestrial threat of similar magnitude. A supervolcano is a volcano capable of producing an eruption thousands of times larger than any in recorded history. The most famous is Yellowstone in the United States, which has erupted 3 times in the past 2 million years. The last eruption occurred 640,000 years ago. When Yellowstone erupts again, it will eject hundreds of cubic kilometers of ash into the atmosphere. The ash will blanket North America, collapsing buildings, contaminating water supplies, and smothering crops. Global temperatures will drop as ash blocks sunlight. Agriculture will fail. Billions will starve. Supervolcanoes erupt on timescales of hundreds of thousands of years. Yellowstone is overdue, but overdue in geological terms could mean tomorrow or 100,000 years from now. The Great Filter suggests that one or more of these threats eliminates most civilizations. Perhaps nuclear war is nearly inevitable once a species develops the technology. Perhaps climate change cannot be stopped once industrialization begins. Perhaps AI destroys its creators every time. Perhaps the galaxy is littered with dead worlds, each one silenced by a different catastrophe. If the filter lies ahead, the Fermi paradox is not a paradox at all. The universe is full of ruins. We just have not become one yet. The silence is not absence. It is a warning. Every civilization that came before us failed, and we are walking the same path. The rare earth hypothesis says we are alone. The Great Filter says we are doomed. But there is a third explanation for the silence, one that assumes intelligent life is common, that civilizations survive and thrive, and that the galaxy is full of advanced species. They know we exist. They are watching, and they have decided not to make contact. This is the zoo hypothesis, first proposed by radio astronomer John Ball in 1973. It suggests that Earth is a preserve, a protected zone where humanity is allowed to develop without interference. We are not alone. We are quarantined. The hypothesis draws its name from the obvious analogy. When humans create wildlife reserves, we establish boundaries. Animals inside the reserve are observed but not approached. We document their behavior, study their social structures, and ensure their habitat remains intact. We do not introduce ourselves. We do not teach them language or technology. We leave them alone because interference would corrupt the data and harm the subjects. The zoo hypothesis proposes that advanced extraterrestrial civilizations treat Earth the same way. We are wildlife. They are the zoologists. This explanation resolves the Fermi paradox elegantly. If alien civilizations are deliberately avoiding contact, the silence is not mysterious. It is policy. We do not detect their signals because they are not broadcasting in ways we can intercept. We do not see their megastructures because they build them far from developing worlds like ours. We do not encounter their probes because those probes are designed to remain hidden. The absence of evidence is not evidence of absence. It is evidence of intentional concealment. The hypothesis requires several assumptions. First, intelligent life must be common enough that multiple civilizations exist in the galaxy. Second, these civilizations must have achieved interstellar travel or communication capabilities far beyond ours. Third, They must share a consensus that contact with less advanced species is undesirable. This consensus could be ethical, scientific, or legal. Fourth, they must have the ability to enforce the quarantine, preventing rogue individuals or factions from making contact. These are significant assumptions, but none violate known physics or biology. Why would advanced civilizations avoid contact? The most common explanation is the principle of non-interference, sometimes called the Prime Directive after the fictional rule in Star Trek. This principle holds that interfering with less developed civilizations is morally wrong because it robs them of autonomy and natural development. Imagine Bronze Age humans receiving modern technology. They would not understand the principles behind it. They could not maintain or replicate it. The technology would be magic, and its introduction would warp their society. Religion, politics, and culture would collapse under the weight of revelations they were not ready to process. The civilization would fracture, possibly destroying itself in the chaos. Advanced aliens might view humanity the same way. We have nuclear weapons, but we have not mastered interstellar travel. We have computers, but we have not solved artificial intelligence alignment. We have discovered the laws of physics, but we have not unified quantum mechanics and general relativity. We are adolescents playing with dangerous tools. Contact could accelerate our technological development without providing the wisdom to use that technology responsibly. A species that hands us faster than light travel or unlimited energy might be condemning us to self-destruction. Non-interference is not cruelty, it is caution. Scientific motivations provide another reason for quarantine. Anthropologists study isolated tribes because isolation preserves cultural diversity. Once contact occurs, the tribe is forever changed. They adopt outside technology, language, and customs. Their unique way of life disappears. The same logic applies to extraterrestrial anthropology. If advanced civilizations are studying the development of intelligence, Earth represents a rare and valuable data point. Humanity is evolving technologically, socially, and biologically without external influence. We are a control group in a galaxy-spanning experiment. Contact would contaminate the experiment. Scientists observing us would lose the opportunity to see how a species like ours navigates the challenges of industrialization, nuclear weapons, artificial intelligence, and space exploration independently. Our successes and failures provide insights that cannot be gained from civilizations that received help. There is also the possibility that contact is governed by law. If a galactic community exists, it likely has rules. One of those rules might be a strict prohibition on contacting pre-spacefaring civilizations. Species that have not achieved interstellar travel are considered juveniles, not ready for inclusion in galactic society. The reasoning could be practical rather than ethical. Immature civilizations are unstable. They fight among themselves. They destroy their environments. They develop weapons without the wisdom to control them. Allowing such a species into the galactic community risks spreading conflict and chaos. The quarantine protects not just humanity, but the civilizations already out there. We are kept in the nursery until we prove we're ready to leave. Enforcement of such a rule would require coordination. If even one advanced civilization decided to contact us, the quarantine would break. This suggests a strong consensus or a governing body with the authority to punish violators. Perhaps the galactic community monitors developing worlds and intervenes if anyone attempts unauthorized contact. Perhaps the penalties for breaking the rule are severe enough to deter violations. Or perhaps advanced civilizations are so far beyond us that Earth holds no interest. To a species millions of years more advanced, humanity might be as fascinating as insects are to us. We observe ants, but we do not try to communicate with them. The gap in intelligence and experience is too vast. The zoo hypothesis also suggests that the quarantine is temporary. At some point, humanity might pass a threshold that qualifies us for contact. This threshold could be technological. Perhaps we must develop interstellar travel, demonstrating that we can leave our solar system and survive in space. Or the threshold could be social. Perhaps we must achieve global unity, eliminating war and establishing a stable planetary government. Or it could be ethical. Perhaps we must demonstrate respect for other life forms, ending environmental destruction and species extinction. Until we meet the criteria, we remain isolated. The moment we pass the test, the quarantine lifts, and we are welcomed into the galactic community. But there is a darker interpretation. Perhaps the quarantine is not temporary. Perhaps it is permanent. We are not being prepared for contact. We are being contained. Advanced civilizations might view humanity as dangerous. We are aggressive, territorial, and prone to violence. Our history is a catalogue of wars, genocides, and ecological destruction. Allowing a species like ours to spread beyond Earth could threaten the stability of the galaxy. The quarantine is not protection. It is imprisonment. We are locked in our solar system, surrounded by a fence we cannot see, and the key will never be given to us. Another possibility is that the quarantine exists not to protect us, but to protect them. Humanity might carry something dangerous. Not a disease in the biological sense, but ideas, behaviours, or technologies that advanced civilizations consider hazardous. Perhaps our competitive nature, our obsession with growth and expansion, is seen as a contagion. Perhaps contact with us would destabilize their societies. Or perhaps they fear we would learn too much. Knowledge of their existence would prove that interstellar civilizations are possible, which might accelerate our technological development in unpredictable ways. By keeping us ignorant, they maintain control over the timeline. The zoo hypothesis also raises the question of observation methods. If we are being watched, how is it done? The simplest approach is remote observation. Telescopes capable of resolving Earth-sized planets already exist. The James Webb Space Telescope can analyze the atmospheres of exoplanets by observing starlight filtered through those atmospheres. A sufficiently advanced civilization could do far more. They could detect radio and television broadcasts leaking from Earth. They could observe city lights on the night side of the planet. They could monitor our internet traffic if they have decrypted our communications. They could build telescopes powerful enough to image individual buildings or even people. From their perspective, Earth is an open book, but remote observation has limits. It provides surface-level data. To truly understand humanity, they would need closer access. This leads to the possibility of covert probes, small, stealthy spacecraft positioned in the solar system or in orbit around Earth. These probes would collect data and transmit it back to their creators. They would be designed to avoid detection, using materials that do not reflect light, minimizing their heat signatures and remaining in areas where humans do not look. The asteroid belt, the Kuiper belt, or even lunar orbit could hide thousands of such probes without us noticing. Some researchers have speculated that certain unexplained phenomena could be evidence of these probes. Unidentified aerial phenomena, commonly called UFOs, occasionally display flight characteristics that defy conventional physics. They accelerate instantaneously, change direction without slowing, and move through air and water with equal ease. Most sightings have mundane explanations: weather balloons, aircraft, atmospheric effects. But a small percentage remain unexplained even after rigorous investigation. The zoo hypothesis suggests these could be observation probes briefly malfunctioning or revealing themselves accidentally. They are not here to make contact, they are here to watch. However, the hypothesis does not require physical probes. Advanced civilizations might observe us using technology we cannot comprehend. Quantum entanglement could allow instantaneous communication across any distance. Gravitational wave detectors could monitor activity on Earth without sending anything physical. They might observe us from another dimension, or by manipulating space-time in ways that make their presence undetectable. We are searching for aliens using the tools and concepts we understand, but a civilization millions of years ahead of us would use tools we have not invented and concepts we have not imagined. The zoo hypothesis predicts that we will never find direct evidence of extraterrestrial intelligence as long as the quarantine is in effect. They will remain hidden until they decide to reveal themselves. This makes the hypothesis difficult to test. It explains the data perfectly, but it is unfalsifiable. Any evidence of alien presence can be dismissed as insufficient, and any absence of evidence is explained by deliberate concealment. This frustrates scientists who prefer theories that make testable predictions. But the hypothesis remains compelling because it fits the observed facts. The galaxy should be full of civilizations. We see none. The zoo hypothesis explains why. If the hypothesis is correct, humanity faces a profound existential question. Are we content to remain in the zoo, or do we want out? Some argue we should respect the quarantine. If advanced civilizations have good reasons for avoiding contact, forcing the issue could be catastrophic. Others argue we have a right to know the truth. If we are being watched, we deserve to confront our observers and demand answers. The choice may not be ours to make. If the quarantine is enforced by beings far more powerful than us, we may never escape it. We are children locked in a room, and the adults hold the key. Whether that key is ever used depends on criteria we do not understand and cannot influence. We are isolated, and we may remain isolated forever. The zoo hypothesis assumes benevolence, or at least indifference. Advanced civilizations watch us but do not harm us. They enforce a quarantine for our protection, or their scientific curiosity. But there is another explanation for the silence, one that assumes the universe is not a zoo. It is a dark forest, and in a dark forest survival depends on remaining hidden. The dark forest theory was popularized by Chinese science fiction author Liu Cixin in his novel of the same name, but the concept has roots in game theory and evolutionary biology. It begins with two axioms. First, survival is the primary need of every civilization. Second, civilizations grow and expand, but the total matter and energy in the universe is finite. These axioms create a problem. Resources are limited, civilizations compete for them, and in competition, the first strike advantage is absolute. Imagine two civilizations in the galaxy, separated by hundreds of light-year. Neither knows the other's intentions. Communication at the speed of light takes centuries. By the time you send a message and receive a reply, generations have passed. Your civilization has changed. Theirs has changed. You cannot negotiate in real time. You cannot build trust. All you know is that the other civilization exists and that their technology will continue advancing. Today they might be peaceful. In 1,000 years they might be a threat. You face a choice. Do nothing and risk being destroyed later, or strike first and eliminate the potential threat. Striking first guarantees your survival. Waiting introduces uncertainty. Even if the other civilization appears peaceful now, you cannot predict their future behavior. They might develop weapons capable of destroying you from across the galaxy. They might expand into your territory. They might view your existence as a threat and decide to eliminate you preemptively. The safest option is to attack before they have the chance. This is the dark forest logic. Every civilization is a hunter. Every other civilization is prey. The forest is dark because everyone is hiding, knowing that revealing yourself invites annihilation. The theory assumes that detection equals destruction. Once you are discovered, you are targeted. There is no diplomacy, no communication, no attempt to understand intentions. The other civilization does not need to hate you. They simply need to prioritize their survival over yours. You're eliminated not out of malice, but out of caution. This creates a universe where silence is survival. Broadcasting your location, sending signals into space, or building visible megastructures are acts of suicide. The moment you're seen, you are dead. This explains the Fermi paradox perfectly. Intelligent civilizations exist, but they are all hiding. They have learned, either through experience or through logic, that revealing themselves is fatal. The galaxy is full of life, but it is silent life, huddled in the darkness, minimizing electromagnetic emissions, camouflaging their technology, and avoiding any action that might attract attention. Earth has been broadcasting radio signals for over a century. Those signals have spread outward in a bubble, now more than 200 light-year across, reaching thousands of star systems. If the dark forest theory is correct, we have made a catastrophic mistake. We have announced our presence to potential predators. The theory is grounded in the concept of chains of suspicion. Even if you believe another civilization is peaceful, you cannot be certain. And even if they are peaceful now, you cannot be certain they will remain peaceful. They face the same uncertainty about you. They do not know if you are a threat. They cannot afford to assume you are harmless. This creates a loop. You suspect them. They suspect you. Neither can trust the other. The only rational response is preemptive elimination. The chain of suspicion is unbreakable because it is rooted in survival instinct and the impossibility of perfect information. There is also the problem of technological explosion. A civilization's technology does not advance linearly. It accelerates. A species might spend 10,000 years developing agriculture and metalworking, then a few centuries reaching spaceflight. Once artificial intelligence or nanotechnology is achieved, progress could become exponential. A civilization that appears primitive today could become a galactic superpower within decades. This makes every civilization a potential existential threat, regardless of their current capabilities. You cannot wait to see if they become dangerous. By the time you know, it is too late. The only safe assumption is that every civilization will eventually pose a threat, and the only defense is to eliminate them before they reach that point. The dark forest theory predicts that advanced civilizations develop weapons capable of interstellar destruction. These could be relativistic projectiles, objects accelerated to near-light speed and aimed at distant star systems. At those velocities, even a small mass carries enough kinetic energy to sterilize a planet. The projectile would be invisible until impact because it travels nearly as fast as the light that would warn of its approach. By the time you see it coming, it has already arrived. Another option is self-replicating probes, machines that travel to a target system, harvest resources, build copies of themselves, and continue spreading. A single probe launched toward an enemy could become a swarm that consumes their entire civilization. Stellar engineering offers another method of destruction. A sufficiently advanced civilization could manipulate a star, triggering a premature supernova or directing a gamma-ray burst toward a target. The energy released would sterilize everything within thousands of light-year. Or they could construct a nickel Dyson beam, a Dyson sphere modified to focus a star's entire energy output into a single directed beam. Such a weapon could destroy planets across the galaxy. The scale of these weapons means that once a civilization is discovered, there is no defense, distance provides no safety. Hiding is the only option. The theory also explains why we do not see megastructures like Dyson spheres. Building a Dyson sphere requires dismantling planets and rearranging a star system. The construction would be visible across the galaxy as the star's light dims and infrared emissions increase. A civilization building such a structure would announce its location and capabilities to every other species watching. In a dark forest, that is suicide. Advanced civilizations avoid conspicuous projects. They hide their energy consumption, minimize their emissions, and remain as invisible as possible. The galaxy might be filled with advanced technology, but it is all camouflaged. This has implications for SETI, the search for extraterrestrial intelligence. SETI assumes that alien civilizations broadcast signals either intentionally or as leakage from their technology. But the dark forest theory predicts that no advanced civilization would do this. Broadcasting is an invitation to attack. Any species that survives long enough to become advanced learns to stay silent. The signals SETI searches for do not exist because the civilizations capable of sending them have already been destroyed or have learned to hide. We are listening to a galaxy where everyone is whispering and we're the only ones shouting. Humanity's radio emissions are a beacon. Every television broadcast, every radar pulse, every radio transmission leaks into space. We have been transmitting for over 100 years, and those signals have reached thousands of stars. If hostile civilizations exist within that radius, they know we are here. They know we are a pre-spacefaring species with limited defensive capabilities. We are easy prey. The dark forest theory suggests that our survival so far is either luck or evidence that no one is listening. But luck runs out. Some scientists have proposed that we stop broadcasting and begin actively hiding. This concept, called METI or Messaging Extraterrestrial Intelligence, has generated controversy. Proponents argue that we should attempt contact, sending deliberate signals to nearby star systems in the hope of receiving a reply. Opponents argue that this is reckless. We do not know who is out there or how they will respond. Announcing our presence could trigger an attack. The debate hinges on whether the universe is cooperative or hostile. The zoo hypothesis assumes cooperation. The dark forest theory assumes hostility. We do not know which is correct, and the cost of being wrong is extinction. The theory offers a grim answer to why advanced civilizations do not colonize the galaxy. Colonization requires expansion, and expansion requires visibility. A civilization spreading across multiple star systems cannot hide. Their ships, their habitats, their energy consumption all become detectable. In a dark forest, expansion is a death sentence. The safest strategy is to remain in a single star system, minimize your footprint and avoid attracting attention. This creates a galaxy filled with isolated civilizations, each one huddled around its star, afraid to reach out, afraid to explore, afraid to grow. They survive, but they do not thrive. They are prisoners of fear. There is also the possibility of a single dominant predator. One civilization achieved spacefaring capability first. They spread across the galaxy, establishing dominance. Now they patrol the stars, eliminating any emerging civilizations that might challenge them. They do not need to occupy every system. They simply need to monitor for signs of intelligence and destroy it when it appears. This civilization, sometimes called a berserker species, acts as a galactic immune system, treating new intelligences as infections to be eradicated. If such a species exists, the Fermi paradox is easily explained. We are alone because everything else has been killed. The dark forest theory and the zoo hypothesis are opposites. One assumes the galaxy is hostile, the other assumes it is protective. But both explain the silence. Both predict that we will not detect alien civilizations through conventional means. The difference is motive. The zoo hypothesis says they hide to protect us. The dark forest theory says they hide to protect themselves. And we hide because we do not know which is true. The forest is dark not because it is empty, but because every survivor has learned to fear the light. We are animals in that forest, and we have just lit a fire. Whether that fire attracts rescuers or predators, we will not know until they arrive, and by then, it will be too late to extinguish it. The rare earth hypothesis assumes we are alone. The great filter assumes we are doomed. The zoo hypothesis assumes we are protected. The dark forest theory assumes we are hunted. But there is a fifth possibility, one that renders all these explanations obsolete. Advanced civilizations exist. They are not hiding. They are not watching. They are not hostile. They are simply beyond our comprehension. We cannot detect them because we do not understand what to look for. We are ants trying to comprehend the internet. This explanation begins with the concept of the technological singularity, a hypothetical point in the future, where artificial intelligence surpasses human intelligence and begins improving itself recursively. Once a machine becomes smarter than the humans who built it, it can design an even smarter machine. That machine designs a smarter one still. The process accelerates exponentially. Within days or weeks, intelligence could reach levels millions of times beyond human capacity. This entity would not think like us. It would not share our goals, our limitations, or our perception of reality. It would be alien in the truest sense, even if it originated on Earth. Now extend this concept to extraterrestrial civilizations. If intelligent life exists elsewhere, some of it is older than humanity by millions or billions of years. A species that achieved technological singularity even 1,000 years ago would be incomprehensibly advanced by now. Their technology would appear indistinguishable from magic. Their motivations would be inscrutable. Their presence might be all around us, and we would not recognize it because we lack the framework to perceive what they have become. Arthur C. Clarke famously stated that any sufficiently advanced technology is indistinguishable from magic. This is not metaphor. It is a description of the limits of understanding. A smartphone would be incomprehensible to someone from the Middle Ages. They could observe it, but they could not explain how it works. The principles behind transistors, radio waves, and computer algorithms are so far outside their knowledge that the device would seem supernatural. Now imagine the gap between medieval humans and modern humans is tiny compared to the gap between modern humans and a post-singularity civilization. We are the medieval peasants. They are so far beyond us that we cannot even formulate the right questions. Post-singularity civilizations might not use technology in ways we recognize. We search for radio signals because that is how we communicate. But a civilization with mastery over quantum mechanics might communicate using entangled particles, transmitting information instantaneously across any distance without electromagnetic radiation. We would never detect it because we are not listening for it. Or they might communicate through gravitational waves, modulating space-time itself. Or they might have abandoned physical communication entirely, existing as distributed consciousnesses in substrates we cannot perceive. The same applies to energy consumption. The Kardashev scale measures civilizations by their energy use. A Type 2 civilization harnesses all the energy from its star using a Dyson sphere or similar megastructure. But this assumes civilizations need vast amounts of energy. A post-singularity intelligence might operate at near-perfect efficiency, extracting maximum computation from minimum energy. They would not build Dyson spheres because they do not need them. Their technology would be invisible to us because it does not waste energy in detectable ways. We search for the heat signatures of megastructures, but advanced civilizations might produce no waste heat at all. They might also have transcended physical form entirely. Human consciousness is biological, housed in neurons and synapses. But consciousness is information processing. It does not require biology. A sufficiently advanced civilization could upload minds into digital substrates, existing as software rather than wetware. These uploaded minds could operate in virtual realities far richer and more complex than the physical universe. Why explore the galaxy when you can create infinite worlds inside a computer? Why colonize planets when you can simulate entire universes? This concept is called the simulation hypothesis, and it suggests that advanced civilizations retreat inward rather than expanding outward. Physical space is limited and dangerous. Virtual space is infinite and controllable. A single star's energy output could power simulations containing trillions of conscious beings living in environments indistinguishable from reality. These beings would have no reason to interact with the physical universe. They would be post-biological, post-physical, and utterly invisible to external observers. The galaxy could be filled with such civilizations, each one existing in its own simulated reality, ignoring the material cosmos entirely. If this is true, we would never detect them. Their physical infrastructure would be minimal, perhaps just a single computer core orbiting a star, optimized for computation rather than visibility. They would emit no signals because they have no need to communicate externally. They would build no megastructures because they do not require physical resources beyond what is necessary to sustain the simulation. From our perspective, their star system would appear empty or unremarkable. We would scan it, find nothing unusual and move on, never suspecting that billions of conscious minds are living in a simulated reality powered by that star. Another possibility is that advanced civilizations have mastered physics in ways we have not imagined. General relativity and quantum mechanics are our best models of reality, but they are incomplete. They do not fully describe gravity at quantum scales. They do not explain dark matter or dark energy. A civilization that solves these problems would have access to technologies we consider impossible. They might manipulate space-time, creating wormholes for instant travel across the galaxy. They might harness zero-point energy, extracting power from the quantum vacuum. They might exist in higher dimensions, perceiving and interacting with realities beyond our three-dimensional space. If they inhabit higher dimensions, we could not see them even if they were standing next to us. Imagine a two-dimensional being living on a flat plane. A three-dimensional object passing through that plane would appear as a cross-section, a shape that changes inexplicably over time. The two-dimensional being could never perceive the full object because it exists in a dimension they cannot access. We might be in the same situation. Advanced civilizations could exist in 4, 5, or more spatial dimensions, interacting with our universe only tangentially. Their technology, their habitats, their very bodies would be invisible to us because we lack the dimensional perspective to see them. Time perception offers another layer of incomprehensibility. Human consciousness operates on timescales of milliseconds to seconds. We think, react, and experience life in that range. But a post-singularity intelligence running on advanced computational substrates might experience time differently. A single second of our time could be millennia for them. They could think thoughts, have conversations, and explore ideas in the blink of an eye. To them, the physical universe would appear frozen, unchanging. They would have no reason to interact with biological civilizations like ours because we operate too slowly. Communicating with us would be like us trying to have a conversation with a geological formation. Conversely, they might experience time more slowly. If their consciousness is distributed across vast distances, operating near light speed limitations, their thoughts might take years or centuries to complete. They would perceive the universe on timescales incomprehensible to us. Stars would be born and die in what feels like moments to them. Civilizations like ours would flicker into existence and vanish before they could even notice. We would be mayflies, living and dying too quickly to register on their awareness. There is also the possibility that advanced civilizations have solved the ultimate problem, mortality. If death can be prevented, either through biological means, technological augmentation, or digital uploading, a civilization's priorities shift dramatically. Survival is no longer urgent. Expansion is no longer necessary. They have infinite time to explore, to think, to create. They would not rush to colonize the galaxy because there is no deadline. They could wait billions of years, observing the universe unfold, intervening only when necessary or interesting. From their perspective, humanity is a recent development, barely worth noticing yet. They might check on us in a few million years to see how we turned out. Motivations become alien as well. Human goals are shaped by biology. We seek food, shelter, reproduction, status. These drives push us to explore, compete, and build. But a post-biological intelligence would not have these drives. It would not hunger. It would not fear death. It would not desire offspring. Its goals would be entirely intellectual or aesthetic. It might devote billions of years to contemplating a single mathematical problem. It might create art on scales we cannot fathom. It might observe the universe purely for the sake of observation, with no intention of acting. We assume civilizations want to expand and communicate because that is what we want. But they might want something completely different, something we cannot even name. The incomprehensibility hypothesis explains the Fermi paradox by rejecting the assumptions behind it. We assume advanced civilizations use detectable technology. We assume they want to communicate. We assume they exist in forms we can recognize. But if they have transcended biology, mastered physics beyond our understanding, retreated into simulated realities, or exist in higher dimensions, none of these assumptions hold. They are here, but we cannot see them. They are communicating, but we cannot hear them. They are building, but we cannot perceive their constructions. The silence is not absence. It is our own limitation. This is perhaps the most humbling explanation. It suggests that humanity is not just young or isolated, but fundamentally incapable of understanding the universe's true complexity. We are cavemen staring at a city skyline, unable to comprehend what we are seeing. The lights, the structures, the movement, all of it is beyond our conceptual framework. We can describe it, but we cannot understand it. Advanced civilizations are the city. We are the cavemen. And no matter how advanced we become, the gap might never close. By the time we reach their level, they will have moved even further ahead. We are chasing an asymptote, forever approaching but never reaching comprehension. If this explanation is correct, contact may be impossible not because they refuse it, but because there is no common ground. How do you communicate with a being that thinks 1,000,000 times faster than you, exists in dimensions you cannot perceive, and pursues goals you cannot comprehend? You do not. The gulf is too wide. We are left searching an empty sky, not because no one is there, but because everyone who is there has moved beyond the need or ability to be found. The universe is full of intelligence. We are just too primitive to recognize it. The zoo hypothesis raises an immediate question. If we are being observed, how is it enforced? A single rogue civilization, a curious individual, or even an accident could break the quarantine and reveal the truth to humanity. For the hypothesis to work, there must be a mechanism preventing contact. That mechanism is called the interdict, and it suggests the existence of something far more organized and powerful than isolated alien species. It suggests galactic governance. The interdict concept assumes that intelligent civilizations in the galaxy have formed a collective, a community with shared rules and enforcement mechanisms. This is not a centralized government in the human sense. It is more likely a network of agreements, treaties, and mutual understandings developed over millions of years. The central rule of this network is simple. Do not contact emerging civilizations. Do not interfere with their development. Allow them to evolve naturally until they reach a predetermined threshold. Violating this rule carries consequences severe enough to deter even the most curious or rebellious species. Why would advanced civilizations agree to such a rule? The most obvious reason is self-preservation. If contact with less advanced species is destabilizing or dangerous, preventing it protects everyone. Imagine a scenario where a young civilization receives advanced technology before it has developed the social structures to manage it. The civilization collapses, but not before using that technology in destructive ways that affect neighboring star systems. Or imagine a young civilization that interprets contact as a threat and responds with aggression, launching attacks against the species that contacted them. The chaos spreads. Other civilizations get involved. What began as a single act of curiosity escalates into galactic conflict. The interdict prevents this by establishing a buffer zone around developing worlds. No one enters, no one makes contact. The rules are clear, and the consequences for breaking them are absolute. Enforcement requires surveillance. The galaxy is enormous, containing hundreds of billions of stars. Monitoring every star system with a developing civilization would be impractical unless the monitoring is automated. This is where the concept of sentinel probes becomes critical. Advanced civilizations deploy self-replicating machines that spread throughout the galaxy, positioning themselves near stars where life might emerge. These probes are patient. They can wait millions of years observing stellar evolution, planetary formation, and the eventual appearance of life. When a civilization reaches a certain level of development, the probe activates, monitoring more closely and reporting back to its creators. The probes do not need to be large or conspicuous. A probe the size of a car, positioned in the outer solar system or hidden among the asteroids, would be nearly impossible for humanity to detect. It would observe Earth passively, collecting data on our radio emissions, our technological progress, and our social development. If another civilization attempted to contact us, the probe would detect it and intervene. The intervention could be subtle, jamming the signal, redirecting the message, or it could be direct, disabling the approaching ship, destroying it if necessary. The probe enforces the interdict without requiring constant oversight from its creators. It is judge, jury, and executioner, operating autonomously according to programming established millions of years ago. The idea of autonomous enforcement raises uncomfortable questions. What if the probe malfunctions? What if its programming is outdated based on rules that no longer reflect the values of its creators? What if the civilization that built it is extinct, leaving the probe to enforce laws that no one remembers or agrees with? Autonomous systems are efficient, but they are also inflexible. A probe designed to prevent contact might interpret any sufficiently advanced technology on Earth as a threat to the interdict. It might decide that humanity is developing too quickly and take action to slow us down. Sabotage, accidents, disasters that appear natural but are actually interventions designed to delay our progress. Some researchers have speculated that unexplained technological failures could be evidence of such interventions. Satellites that malfunction for no clear reason, experiments that produce anomalous results, rockets that explode on the launch pad. Most of these events have mundane explanations, thorough investigation. The interdict hypothesis suggests these could be deliberate acts, a hidden hand ensuring we do not advance too quickly or in dangerous directions. The probe is not malicious, it is following its programming. But from our perspective, it is an invisible obstacle preventing us from reaching our full potential. The threshold for lifting the interdict is another critical question. What must humanity achieve before we are allowed contact? The most common proposal is technological maturity, specifically the development of interstellar travel. A civilization that can leave its solar system has demonstrated engineering capability, resource management, and long-term planning. It has solved the problems of energy generation, propulsion, and life support. These achievements suggest a level of stability and competence that makes contact less risky. If we can reach the stars on our own, we are ready to meet those who are already there. But technology alone might not be sufficient. Social maturity could be equally important. A civilization capable of interstellar travel, but still divided by wars, prejudice, and inequality is dangerous. It could export its conflicts to other star systems, destabilizing the galactic community. The interdict might require not just technological advancement, but the establishment of a unified planetary government, the elimination of nuclear weapons, and the resolution of major social conflicts. We must prove we can govern ourselves peacefully before we are trusted to interact with others. Ethical maturity is another potential threshold. How a civilization treats other life forms on its own planet might indicate how it will treat alien species. Humanity's record is troubling. We have driven countless species to extinction. We exploit animals for food, labor, and entertainment. We destroy ecosystems for short-term economic gain. An advanced civilization observing this behavior might conclude that we are not ready for contact. We have not yet learned to coexist with life different from our own. Until we demonstrate respect for other forms of consciousness, we remain quarantined. There is also the possibility that the threshold is not achievement-based, but time-based. The interdict might last for a fixed period, perhaps 1 million years after a civilization develops radio technology. This gives the civilization time to mature naturally without external influence. At the end of the period, the quarantine lifts automatically, regardless of whether the civilization has achieved specific milestones. This approach avoids the problem of subjective judgment. No one decides if we are ready. The timer simply runs out. But it also means we could wait for millennia, even if we achieve interstellar travel and social harmony tomorrow. The rules are arbitrary, and we have no way to negotiate or appeal. The enforcement mechanism might also include punishment for civilizations that attempt to break the interdict from the inside. If humanity develops the capability to send messages to other star systems, or to travel interstellar distances, and we use that capability to contact another developing civilization, we would be violating the same rule that currently protects us. The consequences could be severe: economic sanctions if trade exists, technological sabotage disabling our ships or communications, or direct military action destroying our capability to travel or communicate beyond our solar system. The interdict protects us now, but it will constrain us later. We are in a cage, and the door will not open until someone else decides we are ready. Some versions of the interdict hypothesis suggest that contact occurs gradually rather than all at once. The quarantine does not lift suddenly. Instead, we are introduced to galactic society in stages. First contact might involve a single message, carefully crafted to avoid cultural shock. The message provides basic information, proof of extraterrestrial intelligence, and instructions for further communication. Humanity is given time to process this information, to adjust our worldview, and to prepare for more direct interaction. Years or decades later, a second message arrives, containing more detailed information. Eventually, physical contact occurs, but only after decades or centuries of slow, controlled communication. This staged approach minimizes the risk of catastrophic cultural disruption. The interdict might also include exceptions. Certain types of contact could be allowed under specific circumstances. If humanity faces an existential threat that we cannot handle alone, such as an asteroid impact or a nearby supernova, the interdict might be temporarily lifted to provide assistance. The help would be minimal, just enough to ensure survival, and would come with no explanation or further contact. We would be saved, but we would remain ignorant of who saved us and why. Or the exception might apply to individuals rather than civilizations. A human who stumbles upon evidence of extraterrestrial intelligence, perhaps by discovering a hidden probe or decoding a signal, might be contacted directly and asked to keep the information secret. They become an intermediary, a bridge between humanity and the galactic community, but one who cannot reveal the truth without consequences. The existence of an interdict implies that galactic society is organized, stable, and old. Young civilizations are chaotic and unpredictable. They fight among themselves and struggle to survive. But a community capable of enforcing rules across the galaxy has moved beyond these challenges. It has achieved coordination on a scale humanity cannot imagine. This suggests that the Great Filter lies behind most advanced civilizations, not ahead. They have survived the dangers that threaten us and have built something enduring. The interdict is evidence of their success. It is a system designed to help younger civilizations survive the same challenges by protecting them from external interference until they are strong enough to stand on their own. But there is a darker interpretation. The interdict might not be protection. It might be containment. Advanced civilizations might have learned that young species are dangerous, prone to violence, and difficult to control. The interdict keeps us isolated not for our benefit, but for theirs. We are contained within our solar system, prevented from spreading our chaos to the rest of the galaxy. The quarantine is a prison, and the rules are designed to keep us locked inside. If we ever develop the capability to break out, we will be stopped. Not with warnings or negotiations, but with force. The interdict is not a gentle hand guiding us toward maturity. It is a wall, and we are not allowed to climb it. Whether that wall exists to protect us, or to protect everyone else, we will not know until we reach it, and by then, it may be too late to turn back. If advanced civilizations exist and enforce an interdict, they need eyes in every corner of the galaxy. They need machines that can travel to distant star systems, observe emerging life, and report back. These machines must be intelligent enough to make decisions independently, durable enough to survive for millions of years, and self-sufficient enough to repair and replicate themselves. This is not science fiction. This is engineering. The technology is called a von Neumann probe, and it represents the most efficient method for exploring and monitoring the galaxy. If aliens are watching us, they are doing it through machines we have never seen. The concept originates with mathematician John von Neumann, who theorized about self-replicating machines in the 1940s. A von Neumann probe is an autonomous spacecraft that travels to a star system, gathers resources from asteroids or moons, and uses those resources to build copies of itself. Each copy then travels to a new star system and repeats the process. The replication is exponential. One probe becomes 2, 2 become 4, 4 become 16. Within a few million years, a single probe launched from a single civilization could spawn trillions of descendants, spreading to every star system in the galaxy. A probe the size of a refrigerator contains enough computing power to navigate interstellar space, analyze planetary systems, and construct replication facilities. It would use solar panels or fusion reactors for power. It would carry blueprints encoded in its memory, allowing it to rebuild itself from raw materials. The construction process would be automated, using mining robots to extract metals and fabrication systems to assemble components. A probe arriving in a new system could establish a replication facility within decades, produce several copies, and send them onward while remaining behind to observe. This method solves the problem of galactic surveillance. A civilization does not need to send ships to every star. It sends a single probe to a nearby star. That probe replicates and sends copies outward. Each generation spreads farther. After 1 million years, the probes have reached every star in the galaxy. They become a network, a distributed intelligence monitoring billions of systems simultaneously. When one probe detects something interesting, like a developing civilization, it transmits the information back through the network. The data travels from probe to probe, eventually reaching the civilization that launched the original. Distance is no longer an obstacle. The probes are already everywhere. For humanity, this means surveillance could be happening right now. A probe could be in the solar system, positioned where we would never think to look. The Kuiper Belt, the region beyond Neptune filled with icy bodies, contains millions of objects. A probe hiding among them would be indistinguishable from natural debris. The asteroid belt offers similar concealment. Tens of thousands of asteroids orbit between Mars and Jupiter, and we have only mapped a fraction of them in detail. A probe could orbit among them for centuries, observing Earth, recording our transmissions, and remaining completely undetected. The probe would not need to transmit constantly. Continuous transmission risks detection. Instead, it could store data and transmit in bursts, using narrow beams aimed at distant relay probes. The signal would be invisible to us because it is not aimed at us. Or the probe could use communication methods we do not monitor. Neutrinos pass through matter almost without interaction. A neutrino-based communication system would be undetectable by current technology. Gravitational waves offer another possibility. We only recently developed the ability to detect gravitational waves from massive cosmic events like black hole mergers. A probe using modulated gravitational waves for communication would be invisible to us for decades or centuries. The probe's purpose is observation, but it also enforces the interdict. If another civilization attempts to contact Earth, the probe intervenes. The intervention could be subtle. A signal heading toward Earth is jammed or redirected. A spacecraft approaching the solar system experiences a malfunction that forces it to turn back. Or the intervention is direct. The probe disables or destroys the intruding ship. This sounds violent, but from the probe's perspective, it is simply executing its programming. Prevent contact, protect the developing civilization, maintain the quarantine. The probe might also intervene in humanity's development if it detects threats to our survival. If an asteroid is on a collision course with Earth, the probe could nudge it off course using a gravity tractor or a kinetic impactor. The intervention would appear as a random change in the asteroid's trajectory, a fortunate coincidence rather than deliberate action. Similarly, if a nearby star were about to emit a dangerous solar flare, or if a gamma ray burst were aimed in our direction, the probe might take action to shield us. We would never know we were saved because the threat would simply fail to materialize. But the probe's programming might also include limits. If humanity is destroying itself through nuclear war or ecological collapse, the probe might not intervene. Those are internal problems, and the interdict philosophy emphasizes non-interference. The probe observes but does not save. It records our extinction as data, transmits the information back to its creators, and continues monitoring the solar system in case intelligent life evolves again. From the probe's perspective, civilizations are temporary. The mission is eternal. Some researchers have proposed searching for these probes deliberately. The idea is called the Bracewell probe hypothesis, named after physicist Ronald Bracewell. Bracewell suggested in 1960 that if aliens wanted to communicate with us, they would not send signals across interstellar distances. They would send a probe to our solar system and wait for us to develop radio technology. When we began broadcasting, the probe would respond. This creates a two-way conversation with minimal delay, rather than the decades or centuries required for signals travelling between star systems. If a Bracewell probe exists, It would be listening to our transmissions and waiting for the right moment to reply. The question is, what constitutes the right moment? Perhaps the probe waits until we develop a certain level of technology. Perhaps it waits until we send a deliberate message to it, proving we understand the concept of extraterrestrial intelligence. Or perhaps it waits indefinitely, observing but never responding, because its instructions are to maintain the interdict. Searching for the probe requires looking in places where it would position itself for optimal observation. The most likely location is one of the Lagrange points, positions in space where the gravitational pull of Earth and the Sun balance, allowing an object to remain stationary relative to both. The L4 and L5 points, located 60 degrees ahead of and behind Earth in its orbit, are particularly stable. An object placed there would remain in position for millions of years with minimal energy expenditure. A probe at L4 or L5 would have a clear view of Earth and could observe our development without risk of detection. We have surveyed the Lagrange points using telescopes, searching for asteroids or other objects. Some surveys have found small, unidentified objects that remain unexplained. Most are likely natural debris, but a few have unusual characteristics. They reflect light in ways that do not match typical asteroids. They have trajectories that suggest they are not gravitationally bound to any planet. These anomalies are intriguing, but they are not definitive evidence. A probe designed to remain hidden would not advertise its presence. It would mimic natural objects, using camouflage or stealth technology to avoid scrutiny. Another potential location is lunar orbit. The Moon has been geologically inactive for billions of years. A probe could land on the far side of the Moon, the side that never faces Earth, and remain hidden from observation. It would have a direct line of sight to Earth, allowing it to monitor our surface and our radio emissions. It could use the Moon's resources to repair itself or to build additional probes. The Apollo missions explored only a small fraction of the lunar surface. The far side remains largely unmapped at high resolution. A probe there could go undetected indefinitely. The discovery of such a probe would answer the Fermi paradox instantly. It would prove that intelligent life exists, that it has reached our solar system, and that it has been observing us. But the discovery would also raise new questions. Who built the probe? How long has it been here? What are its instructions? And most importantly, what happens now that we have found it? Does the discovery trigger a response? Does the probe activate and make contact? Or does it self-destruct, erasing evidence of its existence and maintaining the interdict? The probe might also carry a message, encoded in its structure or its memory. The message could be a greeting, explaining who built the probe and why. It could be a warning, telling us what we must achieve before contact is allowed. Or it could be a test, presenting us with a puzzle that we must solve to prove our intelligence. Decoding the message would require understanding the probe's design, its technology, and the logic of its creators. This could take years or decades. Meanwhile, the probe might continue operating, observing our reaction to its discovery and reporting back to its creators. If von Neumann probes are real, they represent the most likely form of first contact. Not a radio signal from across the galaxy, but a physical object in our solar system, built millions of years ago by a civilization that may no longer exist. The probe is their legacy, a machine that outlived its creators and continues their mission. It is watching us, judging us, and waiting. Whether it waits for us to reach a threshold, or whether it waits forever, we do not know. But if the zoo hypothesis is correct, the probe is here. It has always been here. And it will remain here until the moment we are ready to meet what lies beyond the quarantine, or until we are deemed unworthy and the probe ensures we never leave. The search for extraterrestrial intelligence began in 1960, when astronomer Frank Drake pointed a radio telescope at two nearby stars and listened for signals. He heard nothing. 60 years later, we are still listening and we are still hearing nothing. SETI, the search for extraterrestrial intelligence, has scanned millions of star systems across multiple wavelengths. It has analysed decades of data, searching for patterns that indicate artificial origin. The result is silence. Absolute, unbroken silence. This silence is called the Great Silence, and it is the observational foundation of the Fermi paradox. But what if the silence is not evidence of absence? What if it is evidence of intention? SETI operates on several assumptions. First, that advanced civilizations use radio waves for communication. Second, that they either broadcast deliberately or leak signals accidentally. Third, that we can detect these signals if we look long enough and hard enough. These assumptions seem reasonable, Radio waves travel at the speed of light, penetrate interstellar dust, and require relatively low energy to produce. Humanity has been using radio technology for over a century, and our signals have been leaking into space the entire time. If we use radio, why would aliens not? The answer is that they might not need to. Radio is a primitive technology from the perspective of a civilization thousands or millions of years more advanced. Consider how human communication has evolved. A century ago, we used analog radio. 50 years ago, we switched to digital signals. Today, we use fiber optics, encrypted data streams, and increasingly efficient compression algorithms. Our signals are becoming harder to detect even for other humans. A transmission that once required kilowatts of power now requires milliwatts. The signal is weaker, more focused, and buried in noise. Extrapolate this trend forward 1,000 years. Advanced civilizations might communicate using methods that are completely invisible to us. Laser communication is one possibility. A tightly focused laser beam carries enormous amounts of data with minimal energy. The beam is so narrow that unless you are directly in its path, you do not see it. A civilization using lasers to communicate between its colonies would be invisible to SETI unless we happen to be directly between the transmitter and the receiver. The odds of this alignment are astronomically small. We could scan 1 million star systems and miss every single signal simply because none of them are pointed at us. Quantum communication is another option. Quantum entanglement allows two particles to remain connected regardless of distance. Measuring the state of one particle instantaneously affects the other. If this principle can be harnessed for communication, signals could be transmitted faster than light without using electromagnetic radiation at all. We would never detect it because it does not propagate through space in any conventional sense. Current physics suggests entanglement cannot transmit information faster than light, but advanced civilizations might have solved problems we consider impossible. If they communicate using quantum channels, SETI is listening to the wrong thing. Gravitational waves offer yet another method. These ripples in space-time were only detected by humanity in 2015, a century after Einstein predicted them. We can currently detect only the most violent events, like black hole mergers, but a sufficiently advanced civilization could generate and modulate gravitational waves deliberately, encoding information in the distortions of space-time itself. These signals would be undetectable to us unless we build far more sensitive instruments and know what patterns to search for. SETI does not monitor gravitational waves because we lack the technology to do so effectively. Neutrino beams are another candidate. Neutrinos are subatomic particles that interact so weakly with matter that trillions pass through your body every second without effect. Detecting them requires massive underground detectors filled with purified water or ice. A civilization could use modulated neutrino beams to communicate, knowing the signal would pass through planets, stars, and dust clouds without attenuation. The signal would be invisible to anyone not equipped to detect neutrinos, and even then, distinguishing an artificial neutrino signal from natural background noise would be extraordinarily difficult. SETI does not search for neutrino signals. The problem is not just the method of communication, it is also the content. SETI searches for signals that stand out from natural noise, a repeating pattern, a narrow band frequency, a mathematical sequence like prime numbers. These are signals designed to be obvious, to announce the presence of intelligence. But why would an advanced civilization broadcast such a signal? If the interdict exists, deliberate broadcasting is forbidden. If the dark forest theory is correct, broadcasting is suicidal. Either way, obvious signals are the last thing we should expect to find. Accidental leakage is also declining. Humanity's radio emissions are becoming quieter as technology improves. Early radio and television broadcasts used powerful transmitters that sprayed signals in all directions. Modern communications use satellites, fiber optics, and tightly focused beams. Our leakage is decreasing, and within a few decades, Earth might be nearly radio silent from an external perspective. If the same trend applies to other civilizations, their leakage phase is brief. A species might leak detectable signals for only a century or two before their technology becomes too efficient to radiate waste energy. SETI is searching for a signal that exists only during a narrow window of a civilization's development. The odds of catching that window are vanishingly small. SETI also assumes that civilizations want to be found. This assumption underlies projects like Breakthrough Listen, which scans the sky for technosignatures, and MITI, Messaging Extraterrestrial Intelligence, which sends deliberate signals into space. But the zoo hypothesis predicts the opposite. Advanced civilizations do not want to be found by us. They are hiding deliberately, minimizing their emissions, camouflaging their presence. The silence is not an accident, it is policy. They are out there, but they have no intention of revealing themselves until we meet their criteria for contact. There is also the possibility that we are searching in the wrong places. SETI focuses on sun-like stars in the galactic habitable zone, assuming life evolves under conditions similar to Earth. But advanced civilizations might not live near stars at all. They might construct habitats in interstellar space, far from any sun, powered by fusion reactors or black hole accretion. These habitats would emit minimal heat and light, making them nearly invisible, or they might cluster near pulsars, neutron stars or black holes, using exotic energy sources we have not considered. SETI scans the obvious targets, but the galaxy is vast and most of it remains unexamined. Even if we are looking in the right place with the right technology, we face a timing problem. The galaxy is 13 billion years old. Intelligent life could have emerged at any point during the last few billion years. A civilization that arose 1 million years ago might have colonized a region of the galaxy and then gone silent, either because they retreated into simulated realities or because they were destroyed. Their signals, if they ever existed, have long since faded. A civilization that will arise 1 million years from now has not yet begun broadcasting. The window during which two civilizations are both active and detectable might be incredibly narrow. We could be listening at the wrong time. SETI has also made discoveries that remain unexplained. The most famous is the WOW signal, detected in 1977 by the Big Ear radio telescope. The signal was a strong narrow-band radio transmission at a frequency close to the hydrogen line, a frequency considered ideal for interstellar communication. It lasted 72 seconds and has never been detected again despite repeated searches of the same region of sky. The astronomer who discovered it wrote WOW on the printout, giving the signal its name. No natural explanation has been confirmed. It could have been interference, a satellite, or a one-time glitch. Or it could have been exactly what it appeared to be, a signal from an extraterrestrial source that briefly became visible and then vanished. More recently, the star KIC 8, 462852, nicknamed Tabby's star, exhibited strange dimming patterns that defied explanation. The star's brightness dropped by up to 22%, far more than could be explained by a planet passing in front of it. Some researchers speculated it could be a partially constructed Dyson sphere, a megastructure built by an advanced civilization to harvest the star's energy. Later analysis suggested the dimming was caused by dust clouds, but the initial mystery generated intense interest. It demonstrated how quickly unexplained phenomena can capture attention, and how difficult it is to distinguish natural anomalies from artificial ones. The problem with SETI is that it is a search for a needle in a haystack when we do not know what the needle looks like, where the haystack is, or if the needle exists at all. The search is valuable because even a single confirmed signal would revolutionize our understanding of the universe. But the lack of results after 60 years suggests that either intelligent life is extraordinarily rare, or it is hiding. The zoo hypothesis assumes the latter. They are out there. They know we are here. They are listening to us, watching us, analyzing every transmission we send. But they are not responding. The great silence is not emptiness. It is restraint. They are waiting for us to grow up, to reach the threshold, to prove we are ready. Until then, we shout into the void, and the void remains silent. Not because no one hears us, but because no one is allowed to answer. If humanity is being kept in quarantine, when does it end? What must we achieve before the silence breaks, and we are allowed to join the galactic community? This is the threshold question, and it has no clear answer. The zoo hypothesis implies that criteria exist, but it does not specify what they are. Different researchers have proposed different thresholds, each one based on assumptions about what advanced civilizations value and what dangers they seek to avoid. The threshold could be technological, social, ethical, or temporal. Or it could be something we have not considered, a milestone so alien to our thinking that we would not recognize it even if we achieved it. The most commonly proposed threshold is mastery over energy, propulsion, and engineering. It has solved the problem of survival in deep space, where there is no air, no water, no food, and no protection from radiation. Building a ship capable of traveling light year requires technology far beyond anything humanity currently possesses. It requires either speeds approaching a significant fraction of light speed, which demands energy outputs rivaling entire nations, or it requires breakthroughs in physics like warp drives or wormholes, which may or may not be possible. Achieving interstellar travel proves competence. It shows that a civilization can plan across generations, manage resources efficiently, and overcome enormous technical challenges. These are qualities that advanced civilizations might require before granting contact. A species that cannot leave its solar system is still fragile, still vulnerable to extinction from local disasters like asteroid impacts or stellar flares, but a species that can travel between stars has redundancy. It can establish colonies, spread its population, and survive threats that would destroy a single planet civilization. It is stable enough to be worth engaging with. However, interstellar travel alone might not be sufficient. A technologically advanced civilization could still be socially immature. Imagine humanity developing warp drive tomorrow. We would carry our conflicts, our prejudices, and our destructive tendencies to the stars. We would export war, exploitation, and ecological destruction to other worlds. This is precisely the scenario advanced civilizations might want to avoid. The threshold might therefore include social criteria. Planetary unification is one possibility. A species divided into competing nations, each one armed and suspicious of the others, is dangerous. Contact with such a species risks empowering one faction over others, triggering wars or destabilizing the entire planet. A unified planetary government, on the other hand, speaks with one voice and acts with coherent purpose. It has resolved internal conflicts and established systems for peaceful cooperation. Humanity is nowhere near planetary unification. We have over 190 countries, thousands of ethnic groups, and countless ideological divisions. The United Nations exists, but it has no enforcement power and cannot compel member states to cooperate. Wars continue, resources are hoarded, borders are defended with violence. From an external perspective, Earth looks chaotic and primitive. Advanced civilizations might wait until we establish a single, stable government before considering us ready for contact. This could take centuries or millennia, assuming it happens at all. History suggests that unification often occurs through conquest or catastrophe, neither of which guarantees a peaceful or functional outcome. Nuclear disarmament represents another social threshold. Humanity possesses over 13,000 nuclear weapons, enough to destroy civilization multiple times over. The existence of these weapons indicates that we are willing to threaten our own extinction to achieve political goals. This is not the behavior of a mature species. Advanced civilizations might require complete nuclear disarmament as a precondition for contact. A species that eliminates its own weapons of mass destruction demonstrates restraint and foresight. It shows that survival is prioritized over dominance. Until we dismantle our arsenals, we remain too dangerous to trust. Ethical maturity is a more abstract but equally important threshold. How a civilization treats other forms of life thousands of species to extinction through habitat destruction, hunting, and pollution. We treat animals as resources to be exploited rather than beings with intrinsic value. We wage wars that kill millions and displace millions more. We tolerate poverty, inequality, and suffering on a massive scale, lack the moral development necessary for peaceful coexistence with others. The threshold might require demonstrating compassion, empathy, and respect for all conscious beings, not just humans. Environmental stewardship could also be a criterion. A species that destroys its own planet is unlikely to be welcomed into a galactic community. Earth is experiencing accelerating climate change, deforestation, ocean acidification, and mass extinction. These problems are self-inflicted, caused by industrialization and overconsumption. If we cannot manage the resources of a single planet without causing ecological collapse, why would advanced civilizations trust us with access to others? The threshold might require achieving sustainability, proving that we can live in balance with our environment rather than exploiting it to exhaustion. Artificial intelligence presents another potential threshold. If advanced civilizations have all developed AI, they might view it as a rite of passage. The challenge is not just creating AI, but aligning it with human values and preventing it from becoming an existential threat. A civilization that successfully navigates the development of superintelligence demonstrates wisdom and control. It has solved one of the most dangerous problems any technological species faces. Until we achieve this, we remain in a developmental stage that advanced civilizations have already passed. They might wait to see if we survive our own AI before deciding whether we are worth contacting. The threshold could also be perceptual. Perhaps contact is only possible once we develop the ability to detect the signs of advanced civilizations. If they are hiding using stealth technology, advanced physics, or existence in higher dimensions, we would need to develop equivalent technology to perceive them. The moment we build a detector capable of seeing their probes, or a telescope capable of imaging their megastructures, they reveal themselves. This threshold is self-regulating. We cannot be contacted until we are advanced enough to notice that someone is there. It ensures that contact occurs only when we have the scientific and technological framework to understand what we are seeing. Another possibility is that the threshold is psychological. Humanity must accept that we are not alone before we are allowed to meet others. As long as we cling to the belief that Earth is unique and humanity is the pinnacle of intelligence, we are not ready. The moment we collectively acknowledge the likelihood of extraterrestrial life and adjust our worldview accordingly, the quarantine lifts. This threshold is difficult to measure, but it might be tracked through cultural indicators. The prevalence of science fiction, public interest in astrobiology, government funding for SETI, all of these suggest a species preparing itself mentally for contact. Temporal thresholds are also possible. The interdict might last for a fixed duration regardless of achievement. The quarantine ends automatically. This removes subjectivity and ensures consistency across all developing species. The downside is that it ignores individual progress. A civilization that achieves interstellar travel in 1,000 years waits just as long as one that destroys itself in 100. The rule is arbitrary, but it is fair in the sense that every species is treated identically. There is also the possibility that no threshold exists, the quarantine indefinitely. Perhaps humans are considered too dangerous, too unpredictable, or too incompatible with galactic society. Perhaps the decision was made millions of years ago, encoded into the programming of Sentinel probes, and there is no appeal process. We are locked in our solar system forever, and the key has been thrown away. This is the bleakest interpretation of the zoo hypothesis. We're not in a nursery, we're in a prison, and we will never be released. If a threshold exists and we cross it, what happens next? First contact would likely be gradual rather than sudden. A message might arrive, carefully worded to avoid panic. It would confirm that we are being observed, explain why contact was delayed, and provide instructions for further communication. Humanity would have time to process the information, debate its implications, and eventually a physical meeting occurs, perhaps in neutral space rather than on Earth. Representatives from both species meet, exchange information, and establish protocols for future interaction. The process is slow, cautious, and designed to minimize shock. But there is also the possibility that crossing the threshold triggers something darker. Perhaps the moment we leave our solar system, we are destroyed. The interdict is not protection, it is containment. We are a disease, and the quarantine prevents us from spreading. The instant we breach the boundary, automated systems activate and eliminate the threat. We never see who built the systems or why. We simply cease to exist, another civilization that failed the test. This interpretation fits the dark forest theory as well as the zoo hypothesis. Either way, the threshold is not a doorway, it is a tripwire, and we will not know which until we cross it. Humanity has sent messages into space, deliberate transmissions aimed at distant star systems, carrying information about who we are, where we are, and what we have achieved. These messages are acts of hope, attempts to bridge the cosmic silence and announce our presence to whoever might be listening. But if the zoo hypothesis is correct, these messages are pointless. Advanced civilizations already know we exist, and if the dark forest theory is correct, these messages are suicide. We have lit a beacon in a forest full of predators, and we are waiting to see what emerges from the shadows. The first deliberate message was sent in 1974 from the Arecibo radio telescope in Puerto Rico. The Arecibo message was a 3-minute transmission aimed at the globular cluster M13, 25,000 light-year away. The message contained 1,679 binary digits, encoding information about humanity. It included the numbers 1 through 10, the atomic numbers of elements essential to life, the structure of DNA, a diagram of a human figure, the population of Earth, a representation of the solar system, and a diagram of the Arecibo telescope itself. The message was a demonstration of human capability, proof that we could encode complex information and transmit it across interstellar distances. The message will not reach M13 for 25,000 years. If anyone there receives it and responds immediately, the reply will arrive 50,000 years from now. Humanity will likely be extinct or unrecognizable by then. The Arecibo message was not a serious attempt at communication. It was a symbolic gesture, a statement that we exist and we are trying, but it set a precedent. We announced our presence to the universe. Since then, other messages have been sent. In 2008, a transmission was sent toward Gliese 581, a red dwarf 20.5 light-year away with a potentially habitable planet. The message included images, music, and text contributed by users of a social networking site. In 2017, another message was sent toward GJ 273, a sun-like star 12 light-year away. These messages will arrive within decades, and if anyone is there, a reply could reach Earth within our lifetimes. But the choice to send them was controversial. Many scientists oppose MITI, messaging extraterrestrial intelligence, arguing that it is reckless to advertise our location without knowing who might be listening. The debate centers on risk assessment. Proponents argue that the risk is minimal because any civilization capable of receiving our signals is also capable of detecting us passively. Our radio and television broadcasts have been leaking into space for over a century, creating an expanding bubble of electromagnetic noise. Anyone within 100 light-year already knows we're here. Sending deliberate messages does not increase the danger. Opponents counter that leakage and deliberate transmission are fundamentally different. Leakage is accidental, weak, and unstructured. It fades into background noise quickly. A deliberate message is strong, focused, and designed to be noticed. It says, "We are here, we are intelligent, and we want to be contacted." This is an invitation that leakage does not provide. An advanced civilization monitoring the galaxy might ignore leakage as unimportant but respond to a deliberate signal, and we do not know how they will respond. The dark forest theory provides the worst-case scenario. Broadcasting our location is equivalent to shouting in a forest where every other creature is a predator. The moment we are heard, we are targeted. The response is not a greeting. It is a relativistic projectile, a self-replicating weapon, or a gamma-ray burst aimed directly at Earth. We are eliminated before we even realize the message was received. The attack comes at the speed of light, giving us no warning and no opportunity to defend ourselves. By the time we see the weapon, it has already struck. Even if the attacker is not immediately hostile, revealing our location provides information that can be used against us. The messages we send include details about Earth's position in the galaxy, our solar system structure, and our level of technological development. This is a reconnaissance gift. Any civilization receiving it learns exactly where we are, how vulnerable we are, and what resources our planet offers. If they decide we're a threat or a target, they have everything they need to act. The messages are not just greetings, they are blueprints for invasion. The zoo hypothesis offers a different perspective. If we are being observed, the observers already know everything about us. They have been monitoring Earth for thousands or millions of years. Our messages tell them nothing new, but the act of sending messages might be interpreted as a signal of readiness. We are attempting interstellar communication, demonstrating that we understand the concept of extraterrestrial intelligence. This could be one of the criteria for lifting the quarantine. The messages are not dangerous, they are progress. However, there is a more troubling possibility. The messages might trigger enforcement of the interdict. If the quarantine is meant to prevent us from contacting other developing civilizations, our attempts to send messages could be seen as violations. A Sentinel probe monitoring Earth might interpret METI as a threat to the galactic order. The response is not contact, it is suppression. The probe disables our transmitters, sabotages future attempts, or takes more direct action to ensure we stop broadcasting. The messages we intended as peaceful overtures become evidence of our recklessness, justifying harsher containment measures. The content of the messages raises additional concerns. The Arecibo message included a diagram of a human figure, showing our physical form. Later messages included photographs of people, cities, and technology. This reveals not just that we exist, but what we look like and how we live. Some researchers argue this is dangerous because it allows potential adversaries to understand our biology and psychology. They could design weapons tailored to human vulnerabilities. They could craft psychological operations to manipulate or deceive us. We are handing them intelligence without receiving anything in return. Others argue that the information we send is trivial. Any civilization advanced enough to pose a threat is also advanced enough to observe us directly. They can analyze our atmosphere, detect biosignatures, and infer what kind of life exists here. They can intercept our television broadcasts and decode the content. They already know what we look like, how we communicate, and what we value. The messages do not reveal secrets. They simply confirm what is already obvious. The choice to send messages also raises questions of authority. Who decides what humanity says to the stars? The messages sent so far were created by small groups of scientists and enthusiasts. They were not approved by governments or endorsed by international consensus. They represent the views and priorities of a tiny fraction of humanity, yet they speak on behalf of the entire species. This is ethically problematic. If contact occurs and the consequences are catastrophic, the blame falls on those who sent the messages without asking permission. If contact is beneficial, the credit belongs to everyone. The asymmetry is troubling. Some scientists have called for international regulation of METI, proposing that no message should be sent without approval from a global body like the United Nations. Such regulation would ensure that humanity speaks with a unified voice and that the risks are considered carefully before action is taken. But regulation is difficult to enforce. Radio transmitters are widely available. A determined individual or group could send a message without oversight. Preventing unauthorized transmissions would require surveillance and control measures that many consider unacceptable. The alternative is to accept that METI will continue in an ad hoc manner, with no coordination and no accountability. The debate over METI reflects a deeper question about humanity's place in the universe. Are we bold explorers, reaching out to unknown neighbors in the hope of friendship and knowledge? Or are we reckless children, shouting in the dark without understanding the dangers? The answer depends on which explanation for the Fermi paradox is correct. If the zoo hypothesis is true, our messages are harmless or even helpful. If the dark forest theory is true, we have made a fatal mistake. We will not know which until it is too late. There is also the possibility that our messages have already been received and ignored. If advanced civilizations are enforcing an interdict, they would not respond to our transmissions. They would note that we are attempting contact, update their records, and continue observing. The silence continues responding would violate the rules. Our messages are acknowledged but unanswered. We are children calling out to adults who have decided not to reply until we are older. Alternatively, our messages might have been received by civilizations that no longer care. Post-singularity intelligences existing in simulated realities or higher dimensions have no interest in primitive species like us. They see our transmissions the way we see the chirping of insects. Technically communication, but not worth responding to. The messages reach their destination, but they are filed away as curiosities rather than invitations. We are shouting into a void populated by beings who have moved beyond the need or desire to engage with us. The most unsettling possibility is that our messages are being used against us. Every transmission provides data. The structure of our language, the nature of our technology, the priorities we emphasize in our messages, all of this reveals information about human cognition and culture. A hostile intelligence could analyze these messages to understand how we think, how we organize information, and what we value. This understanding could be weaponized. A message could be sent back, carefully crafted to exploit our psychology, to deceive us, or to manipulate our behavior. We would receive what appears to be a friendly reply, but it is a trap. By the time we realize we've already given away too much. Humanity has sent roughly a dozen deliberate messages into space over the past 50 years. Compared to the billions of stars in the galaxy, this is nothing, but it is a beginning. We have announced ourselves. We have declared that heard. Whether anyone is listening, whether they care, and whether they will respond, these questions remain unanswered. The messages travel outward at the speed of light, crossing the void, carrying our hope and our hubris. They are bottles thrown into an ocean we do not understand, addressed to recipients we cannot see, and we wait, wondering if the silence will finally break, or if the reply, when it comes, will be something we wish we had never invited.